In the last video for section 9.2, I showed you how to find the molar mass of an element. Remember, for something like sulfur or copper, those are elements, we can look on our periodic table and we just look and we find sulfur, which is right here, and we just use the atomic mass, but instead of writing a U for atomic mass units, we write a G for grams after it. And that's how many grams are in a mole. And the same thing for copper, which is right here, 63.546 grams would be the molar mass. But sucrose is not an element. Sucrose is a compound. So how do I find the molar mass of a compound? Where did I come up with this number of 342 grams? So let's take a look at that in this section, section 9.3 of your textbook, compounds and the mole. So I'll give you a few seconds to pause the video and write this down. Okay, so this is a pretty short section. So section 9.3, compounds in the mole. I'm going to show you how to find the molar mass of compounds. So to find that, find the mass of the molecule by adding the masses of the atoms they contain. So my example is going to be water. If I take a look at water, water contains 2 atoms of hydrogen and 1 atom of oxygen. So what I do is I multiply 2 times the molar mass of hydrogen, which I get out my periodic table, and I see it's 1.00794 grams. So I say 1.00794 grams per mole. And I add that to, there's just one of these, so the molar mass of oxygen is 15.9994. 15.9994 grams per mole. And when I multiply this and I add this together, now I'm going to round here and not pay as close of attention to my significant digits here because these are really long numbers. So I'm going to go with 18.02 grams per mole. I multiplied 2 times 1.00794 and added that to 15.9994. So plug that into your calculator to make sure you're doing that properly. Okay, so what about glucose? I'm going to use pretty rounded numbers here because especially when I'm finding the mass on my balance, I do not have the precision of these numbers here. So I am going to round off to the nearest whole numbers for this because that's what my balance would handle. So I see here that I have 12 carbon atoms. So I would multiply 12 times the molar mass of carbon, which is right here, and it's 12.00 or 12.011. I'm just going to round that off to 12. So 12 grams per mole plus 22, because I have 22 hydrogens, times the molar mass of hydrogen is 1.00794. So times 1 gram per mole, plus I have 11 moles of oxygen, so it's 11 times the molar mass of oxygen is 15.9994 grams per mole. So I'm going to round that off to 16 grams per mole. And so when I add up these numbers. Okay, so 12 times 12 is 144 grams per mole, plus 22 grams per mole, plus 11 times 16 is 176 grams per mole. I get 342 grams per mole. Okay, so that is how you do a problem like that.